This is Geo Kedareshwar Kiran from 5th Sem Electrical Department. Today I am presenting about load management strategies and maximum demand control. How load management is controlled when there is a maximum demand. So smart energy optimizing load management and maximum demand control. This PPT will explore the load management and maximum demand control reduces peak electricity demands and associated cost will be continued strategies to contribute the grid stability and energy efficiency focusing on their applications industrial commercial and unity sectors small scale unity sectors. What are the maximum demand control of reducing peak electricity demand? Let us see. Now, what is load management? In generally, the load means the requirement of strategy balancing the electricity supply. The load management is a general supply controlled through demand rather generations. It is a crucial approach for optimizing energy use and cost. Peak shaving reduces electricity demand during periods and highest usages include load shifting, load shading, and load shaping, snapping. These enables the cost infrastructure upgrades. Cost infrastructure upgrades means minimizing the cost and efficient of electricity demand, reducing the highest usages. So next one, understanding the demand and its impacts. Maximum demand. The maximum demand, the highest amount of power drawn from the grid to any given time within the billing period. So what is the highest amount of power they consume to before giving time through billing period is called the maximum demand. Cost implications, the MD charges and account approximately 20% industrial electrical bills, significant impacting the operational cost. And unity innovatives, the untitled design terrifies the peak demand reduction of promoting more stable grid operations. The stable grid operations means reduction the peak intensity of load. Cost reduction means efficient managing of maximum demand and reduces penalties and lower overall electricity expenditure. The cost reduction is generally scalable of maximum demand, reduces the penalties and over electricity expenditure means the amount we consume on electricity. Key load management strategies, scheduling the operation of energy intensive equipment and avoid simultaneous peak loads and efficient through efficiency upgrades, invest more equipment efficiency upgrades and reduce overall base load consumption. Demand response, so the consumer reduce the demand response through the shift load response and signal through utility factor. Rate design, the time and usage of the load of peak load efficiency electricity and usages. So load control strategies in practice. Fixed priority strategies. Shared over priority load first during peak times, restoring them last. This ensures critical operation and maintained factor. Through rotating strategies, distribution load shielding equally among all loads, maintaining a more consistent loads levels and conformate protection of different areas. So the load is taken from the different areas, managing the maintenance of the level of the comfort and domestic needs in different local or urban areas. So combinations and strategies, tailored approaches through fixed priority of rating methods and designed through specific building process requirements. The process requirements generally need the fixed priority of scalability and design specific range of rotating strategies. Next thing, technology and automation in load management. So in general, the load how we calculate is kilowatt per hour kWh. So building automation systems integrate HVAC and appliances, and centralized control. The network infrastructure and parent level controls through user interface and end devices. Through the different types of smart meters and IoT devices enable real-time monitoring and the control over the emergency consumption. Advanced algorithms predict automatically reduce peak through load and platform like grid point and facilitate scalable cloud based on load management. So next thing is benefits of effective load and demand control. Cost saving, significant reductions in electricity bills by minimizing the expensive peak demand charges. Grid reliability, improved stability and electricity grid, reducing the need for costly peaking power plants. And energy efficiency through enhanced overall system efficiency, environmental sustainability, and through optimized usage. Operational flexibility, increase the comfort of greater operational flexibility for business and consumers. So next thing, challenges considered. What are the challenges considered? The consumer participation and requires the active engagement and behavior challenges of end users, how the consumer will consume the electricity, on which initial investment he will consume, and the concept complexity and scalability factors doesn't multiply the load factor, deriving the system energy efficiently. Initial investment is about upfront cost and control technology, smart meters and infrastructure upgrades. Data integration, need a robust communication and effective data integration across platforms. So these all are come under challenges and considerations. The consumer participation requires means the system complexity is indirectly dependent on the consumer participation and data integration. These all come under the system complexity challenges according the multiple load factors and system shamelessly. So case study and industrial maximum demand reduction. What is the case study and system maximum demand reduction? On the left side we can see the graph before and after savings and the techniques they used. Example, an industrial plant successfully reduces its maximum demand from 2736 kilowatts to 2220 kilowatts, saving achieved approximate monthly saving up to RM of 17,000 minimal investment. And techniques implemented, processing the engineering strategies and load scheduling through equipment upgrades. These demonstrates about the significant sustainability and cost effective of proactive MD control. MD means maximum demand control. It demonstrates the significant sustainability and investment of minimal rate, approximate monthly, yearly, and these all can be reduced by the techniques of equipment upgrades and load scheduling. Load scheduling means peak load scheduling and demand load scheduling according to the mornings and evenings. So next one, so the conclusion and the future outlook is about essential for saving, smart technology driven progress, and collaboration is key, and innovation continues. Actually, the drives program progress through essential for saving, load management and maximum demand control are critical for both cost reduction and energy conservation. So the smart technology driven progress means the advance in a smart technology enable more sophisticated and automated energy management strategies. Collaboration is key. Optimal result requires strong collaboration between the business and the individual consumers. Innovation continues. Ongoing innovation furtherly integrated renewable and energy storage into the future load control systems is a main motto for the innovation continues. Through these all energy essential savings and smart technology driven programs and collaboration keys, the optimal we can achieve the optimal result and the benefits of individual consumer and energy conservation reduction cost through the energy management strategies. So these all help us in advanced smart technologies and enabling the innovation continues. Through this we can integrate the renewable energy storage sources through the different load control systems.